Good afternoon, everyone. Thank you for coming to this talk. This is the last one for the day, so we're not going to take it long. We'll probably be about 20-25 minutes, and we're looking to leave some time at the end for any questions that you might have. There's two of us that are doing the presentation here. My name is Michael Coburn. I'm a consultant. I've been with Percona now going on 3 years. On Friday, I'll be celebrating my 3-year anniversary. I used to live in the States, but now I moved to Costa Rica. And I have the opportunity to work with anywhere from 3 to 10 different customers per week. And I get to see some of the good and some of the bad and some of the in-between environments out there. So what I'm going to try and deliver in the first half of this talk is my perspective on what some of the advantages are of using Percona Server versus some of the other distributions out there. Okay, I'm going to give Chris Jeffus an opportunity here to introduce himself as well.
Thank you, Michael. Welcome everyone. Hope everyone's enjoyed the conference thus far. Just got one more day left. It's been an exciting conference so far. I've been with Percona for about 6 months or so. Prior to that, I was with Oracle. Been in the MySQL space for a number of years. So my part of the second half of the talk will be to talk, in my perspective, of some of the advantages of the Percona server. Michael.
Thanks, Chris. Okay, so when deciding what to use for your database system, you've probably already made a conclusion that you're going to use a SQL or NoSQL choice. When you're thinking about the SQL opportunity, you're looking at a number of different options. You've got anywhere from the Postgres's, from the Oracles, the IBM's, the DB2, and then you've got MySQL. Well, we're not going to focus on any of those other ones. We're going to focus on just what you can get from an RDBMS that's based on MySQL. Once you focus on MySQL, you've still got choices. Okay, one of the earlier ones that's not really around much anymore is the Drizzle. Some of them that still are around, there's the Oracle Community version, which is generally the most popular one out there. Then you've got the MariaDB, which is sometimes called a fork, sometimes called a set of patches, depending on which version of Maria you're looking at. And that's based on Community version of MySQL. The third option is Enterprise version from Oracle, and that's where you'll still get the same features, at least that are in the Community version, but when you buy that support contract, you're eligible to use their Enterprise packages, which include some additional plugins, like the thread pool, like connection pooling, like the audit plugins. So there's a few extra things you can get with an Enterprise package. The fourth, and particularly my favorite, is Percona Server, and I say that from a consultant perspective of having a choice of what I can help a customer choose when they're looking to make a decision on this. And what I mean by that is Peter Zaitsev, who was just in this room, our CEO, he says to us, look, we have a substantial investment in the development skills that we've got that work for Percona. That's a real cost. We're paying people salaries, and they're supporting families and whatnot. And originally when I joined Percona and I saw that, I thought, well, you know what? I'm going to walk into this company. He's going to say, push Percona IP all the time. And he has a completely opposite take on that. He says, you should be recommending, he says, Michael, you need to recommend the best tool for the job for this customer. He says, forget whether it's Percona, forget whether it's Enterprise or MariaDB. You need to think about their needs first and put that first and foremost in your mind. Okay, so that's good. I've got latitude. But I still say, like I said earlier on, I tend to choose Percona Server. Okay, and I choose that for a lot of different reasons. We're going to tick them off, kind of a checkbox kind of approach. But at the high level, I pick it because it has more visibility, because it typically makes your queries run faster, and because it's widely deployed and tested. Okay? Those are the three main highlights of why I think it's important that you consider using Percona Server for your next deployment. Okay? Now let's focus on some of the nuts and bolts here. Why do I say it makes your queries run faster? Well, it's got different ways that we've helped scale the I/O. The I/O stands for the input and output, and that generally talks about the disk. Okay? In any database world, we're trying to answer a question for a user, for a client, whether that's a MySQL command line client or whether that's a web app making a query to the database. That needs to be predictable. That needs to come back in some reasonable expectation of time. We want to make sure that it comes back quickly as possible. But we also don't want to blow the bank on it. We realize that some people are bootstrapping their company and they're trying to keep it as affordable as possible. So when they go to the Amazons or the rack spaces for some hardware, they're going to say, look, I have a fixed budget. I got $1,000 a month or some number like that. This is what I can afford to do. Okay, Percona tries to help you in that regard. We try to make sure that given the choice you make with your spend on your server, whether it's virtualized or physical, how can we help you optimize it? Some of the things we focus on, specific to MySQL, is that we help you tune the InterDB log block size. Okay? Does anybody know what the InterDB log block is? Where it might be used? Okay, that's fine if you don't. This relates to the redo log. That's the log that keeps track of all the changes, all the inserts, updates, and deletes that are coming into the database that are acknowledged, but that aren't necessarily committed durably to disk. It's there in case the database server experiences a failure. Okay, so what? We got this thing doing all this logging. Well, as it turns out, we did some performance testing. And by default, this thing's running at the default of 512 bytes, which is designed for the 30 years we had of spinning platter drives. Right? Everybody got used to that. We'd optimized for a boatload, multiple decades, for making spinning platter type behavior faster. One of the common optimizations was random writes in a spinning platter world were really, really slow. It took physical time for these drives to spin to the right location, and then the drive heads to seek. It would be exponentially more expensive to do a lot of random writes. So we would try in the database world to convert this to a serialized write. We tried to say, okay, don't do all those random writes. Let's batch them in memory for a little while and then flush them out in a serialized fashion to disk. Great. So that's some of the other optimizations that already exist in MySQL. Well, why am I talking about the log block size? Well, one of the greatest innovations that we have in a long time for disks was the move to SSD drives. Okay? There's nothing moving anymore in these things. It basically made a random write as free as a random read is. They both cost in terms of the same duration. There's no spinning devices in there. There's no seek times anymore. Okay, there still is obviously latency because there's electronics involved, but it's a lot faster. So what did that mean? Well, it also meant that when we did some benchmarking, 512 bytes wasn't optimal anymore. We actually suggest that you can take that thing up to 4,096. So a 4K log block size meant we could get better throughput for writes when we're configuring the redo log. Okay? So that's one of the optimizations that we made available that you can edit. And before I go too far, these ones that are highlighted in the Courier font, these are ones related to specific variables that you can tune if you know what you're doing or you ask Percona for some help. But these are the premises is that you can modify these already existing variables or maybe new variables that exist in Percona Server. And I try to show how they're different than both Maria or Community Edition. And for all intents and purposes, I tend to think in my mind of enterprise and community as about the same equivalency. They both come out of Oracle. They both use the same kind of stable defaults. Okay. One of the other options that you can modify is the InterDB flush method. Now, I believe Oracle already has a lot of this implemented, but we have a little bit more extended. The purpose behind this, tuning the flush method, is the difference between having Linux cache this stuff in memory and also in the buffer pool or not. The not meaning InterDB can talk directly from the buffer pool to the disk and not do any intermediary caching in Linux. And why does this make sense? Well, if the buffer pool already has a copy of the data, there's no point in letting Linux do a secondary copy of that in its own, a data agnostic Linux file system cache. You don't need to do that. Let InterDB talk directly to the drive, and therefore you get a lot more free memory that doesn't have to be checked and invalidated under a lot of conditions when it's looking to read and write. Okay, so some of the options you'd want to consider. By default, it's going to do an fdata sync. What we allow you to do is to choose ODirect or all ODirect, which makes it a lot faster for for InterDB to both read and write data from the drives. Okay, and the last one, there's two models of doing checksumming. One of them is based on the old InnoDB checksum method, and there's also a newer one based on CRC32. And the point to take away with here is twofold. CRC32 has a higher risk of collisions, but it's much, much faster to compute a checksum using CRC32. And the second thing, probably even more important, is that the newer Intel chips, they can do offloading onto the hardware, onto the CPU to do these CRC32 checksum computations. So that's a win. You're not doing it in software anymore. You're moving it on to the CPU to do some work. So tuning the InterDB log checksum algorithm to use CRC32, huge win. Okay. Some of the other improvements that we made, we've got multiple hash index partitions. And what this means is that on secondary indexes, MySQL doesn't have to depend just on the B tree model anymore. When it gets these indexes loaded into memory, it can compute a hash across these, and that makes for faster lookups on indexes that are in memory. Okay? So that's a good thing. Now, why do I say multiple? That means that when updates are happening, they need to invalidate sometimes records that are in these indexes. Well, if you've only got one big index, then a lock needs to be held across all of it, and that lock can be blocking to other readers and other writers to it. So what we do with the multiple one is we split it up into, there are now multiple different hash indexes, which makes it so that a smaller subset of those records are going to be locked at a time. Okay? It's the same thinking that exists in the other streams of MySQL that relate to the multiple buffer pools, InterDB buffer pools. Okay? And the last feature that we've got with regards to making your queries run faster has to do with the splitting of the global mutex. In a lot of cases, the whole buffer pool needs to have a mutex held over it. And for those who don't know the word mutex, it means mutually exclusive lock. What it basically means is for one reason or another, the database says, I'm going to do this big operation, and all of the records in this buffer pool need to be frozen right now so I can do this thing. It's generally very quick, but it does lead to contention. If you have a lot of things happening in your database, a lot of concurrent queries, they're going to wait on this mutex, and you're going to see that in terms of stalls in your application. Your developers will talk to you and say, hey, what the heck's going on? Why did things just get slow there for a second? They're going to see it on graphs. And when you start digging, you're going to see these mutexes. Well, what we did is in a lot of cases, we chose an optimization that said, all right, in this code loop here, we don't need to lock the whole mutex. We can get a much smaller type of mutex. There's about 8 different ones. I didn't list them all, but we've broken it up so it's a lot more granular, so we don't lock as frequently and for as long. Okay? One of the other improvements has to do with server consolidation. It's going to help you not have to buy as many servers, or if you've already bought them, let's take you back down a little bit to less servers. So what we've helped you do is use NUMA. NUMA stands for the way that memory gets allocated on a core. If you've got more than one core in your database server, the memory is going to get all allocated by the InterDB buffer pool along one core, one set of memory banks, and then it will start filling the second one. Great, that's theoretical. The actual impact is you're going to call up Percona or whoever's helping you with your database, and you're going to say, hey, listen, my server's only using about 3/4 of RAM, according to top, but I'm already starting to see swap. That doesn't make sense. I should only be swapping once RAM's completely used. And that's an artifact of the way NUMA's been implemented in your server. So what we've done is we've taken advantage of a couple options to actually interleave the memory and to also allocate all of that RAM to the buffer pool at database startup. And that takes care of making sure you don't swap too early. Okay? One of the other ones is the thread pool implementation. You can buy this as part of your enterprise package when you go to Oracle, or you can get our open source version, which basically means, hey, your environment regularly has 10,000 connections into your database server. Okay, that's a lot. If they were all doing queries at the same time, your database server probably couldn't sustain that. So this thread pool still allows those connections to come in, but it's kind of a limiter. It's got a way of round-robining and choosing which queries are going to actually execute against the database server. And why is this practical? It means that you can have your servers consolidated from maybe 2 or 3 into 1, still support that large pool of connections, and that maybe things will take longer, maybe they won't, but the thread pool is going to give you that option, that flexibility to at least test it out. This is my last slide, and I'm going to pass it over to Chris. Being able to have visibility into the database is really, really, really big as a sysadmin or a DBA. This is one of the best features as myself as a consultant I need to have. That means I can jump into your environment, know nothing at all about what's going on with you, and I can start being productive right away. Okay? So what I like to look at first is your slow log. We offer some advantages there. We've got microsecond resolution on how long those queries ran for. That's really key. The other biggest part, though, is we log a whole bunch of extra data. We log a lot of info about what's happening within InnoDB. We also log the thread ID, and that lets me correlate for a given transaction what actually happened, what actually transpired. I can tell that it first did an update, and then a select, and then an insert later, all within that one transaction. That's some pretty powerful stuff you can often share with your development team to track back problems. So the slow query log from Percona Server, to me, is probably one of the best advantages. One of the other advantages has to do with the user statistics. Okay, we publish a few extra information schema tables, and that's what the IS stands for, information schema. If you enable this feature, you're able to see what volume of clients are connecting, how long they've been running for. It's kind of like a roll-up view of what's happening within the database. It does this across the indexes and across the tables. So it can tell you where are my hot tables, which one have been read from the most often, which of my indexes are the most popular. Reverse the order, which of my indexes have not been used because they're not in the list yet. Those are candidates to be dropped from your schema. Okay? And the last one is, it's not that big of a deal really, but it's kind of helpful to be able to access the process list by using select statements. Really, really convenient versus trying to do show process list and then, grep out your differences or awk or whatever tool you want to use. Much easier to use SQL. Okay? And with that, I'm going to pass it over to Chris.
Thank you, Michael. As I stand here and listen to all these improvements you're talking about, I can't help but think, wow, this could save me money. Who likes to save money? Anyone, right? All these improvements here can save one money. All the additional things that he's talked about. So looking at my slides, for example, spending less time tuning. Percona offers the configuration wizard. So one can fire up this wizard that Percona offers, look at their Percona database, determine what could be tuned, and get it right from the get-go, instead of spending a lot of time down the road, resources, DBAs, sysadmins, trying to understand, why is my database not operating at an optimal performance. With the Percona server, there are a higher number of variables that one can tune. There's a plethora of status variables that you can look at. So a seasoned DBA could look at the performance of the database and determine, what knobs should be tuned and tune it properly for a specific workload. Again, saving time and money. Looking forward, you've got your application the way it is today. Tomorrow you anticipate that your business is going to grow 10x. How do I plan for that? How do I make sure that when I get to that point, I haven't just simply thrown additional hardware at it or hired additional DBAs or done other things that may not have made the most sense? We can use these metrics. It's a plugin that you can enable. We can look at what your database is doing today and somewhat project where it's going to be tomorrow and make educated changes, reducing the errors of just throwing additional resources at it unnecessarily. Higher uptime. Downtime usually means lost money. No one wants to have their database down. Customers come, the website's down, they sometimes will go elsewhere. So we want the database to be up as much as possible. So how do we do that? Traditionally, when there is a corrupted InnoDB table, for example, the server will just crash with an assertion error. With Percona Server, you can configure it as such that it would warn and take that table offline. It may incur some downtime, but not take the entire site down potentially. So a benefit there to having that particular configuration of Percona Server. Idle transactions. Having connections run around or sitting there idle can use up resources. So configuring this to purge those on a timely basis can help free up resources and allow the site to continue running smoothly. Locking tables for backup. Traditionally, when you take a backup, you do a flush tables with read lock, locks all the tables. The database is in a read-only state, which can incur downtime. With the feature in Percona Server of locking tables with backup, that is greatly minimized, thus keeping the database up for an extended period of time. The online global transaction ID. Traditionally, the master server needs to be put in a read-only state, similar to taking backups where the database is, somewhat offline. With Percona Server, you can configure global transaction IDs and replication by not having to do that, thus improving downtime, improving uptime, and reducing loss of money. Sharding. Anyone familiar with the term sharding? Splitting your data into smaller chunks to be able to scale your writes. Percona Server is, as we've mentioned, all these benefits of Percona Server, getting it well tuned, allowing your database to make better use of the resources you have available. You can delay the point at which you need to shard. With the announcement that we had during the keynote, TokuDB, which is highly optimized for write-intensive workloads, one can now even further delay the need for scaling using the technique of sharding. TokuDB. Did you want to speak?
Go ahead.
So if anyone was in Peter's talk earlier about TokuDB, as he mentioned, there's lots of advantages of it. It's highly optimized for write-intensive workloads. It makes use of the fractional tree index as opposed to the traditional B tree index. Allows for read-free replication. It's not something that's it's installed as part of Percona Server, but it is something you can download separately today and integrate into your Percona implementation. but definitely something I would encourage everyone to look into and as they evaluate Percona Server. Questions? Do you have anything you want to add? Questions, anyone? Everyone's ready? Ready for the... Sure.
Tuning parameters for the TokuDB
Hmm?
are going to be different from the innovation side.
Yes,
Is there good documentation on your side?
there is documentation on our site, yes, and as we have, as we integrate more with our the two sites, there will be more and more integration to the streamline of documentation. But currently, there are links and such that point into the documentation. But yes, it is a different storage engine, just like with InnoDB or MyISAM. There's going to be different knobs to tune and such. Okay. Other questions? Yes, sir.
What's the default storage engine that you get when you download the Percona Server?
It's in InnoDB. That's been changed since a couple of versions ago, right? It used to be MyISAM, but now it's in InnoDB.
So is it exactly the same as the Oracle distribution, or is it?
I can answer that. No, that's a good question. So what we've done is Percona Server is actually a compendium of multiple parts. I'm sorry, I'm just getting over a cold. When we say Percona Server, it actually means two things. We've enhanced both the binary. That means we get more connection variables. We get a whole bunch of maybe about 50 more variables than you get with Community. That means I get better insight as a consultant into what's running inside the database. Well, the storage engine itself is still known as InnoDB, but we've rebranded it as ExtraDB. Percona ExtraDB. So it's InnoDB with enhancements. So earlier when we were talking about ones related to I/O capacity or I/O scalability, that's where we've actually modified not Percona Server MySQL, but we've modified the storage engine. And it's known as ExtraDB. And so we've got a server team that deals in these two different spheres. One guy's work with what it looks like on disk, and the other guys work with, hey, this is how the database server runs, and when it's actually up in memory, here's how it's behaving differently. Okay.
So extra DB is kind of like the default, similar to the
Yeah, you're right. Yeah. So it's interesting because we use the phrase ExtraDB when we talk about it to highlight that we're using an enhanced, it's InnoDB with patches, but when you go to make configurations, to my knowledge, you'll never see a reference to ExtraDB in any of the tuning. Everything is going to be an InnoDB underscore, kind of parameter you're going to modify. Okay, so you're not going to be at any different waters than you'd be if you were looking at Community. All you're going to see is that there's going to be new options, additional options you can tune.
So the extra backup and those kind of tools, they take care of whether it is whichever storage, does it also take care of TokuDB?
That's a really good question. So the question is, does Percona Extra Backup take care of checking to see whether it's InnoDB or ExtraDB or TokuDB? Well, that's a little more complicated. We just announced on Friday, or I'm sorry, on Tuesday that we were acquiring TokuDB. So Percona Extra Backup does not yet support TokuDB. We are planning to integrate it, and what I heard today is that we're actually going to be releasing it for free. So it's going to be as GPL'd out as that we do with our current Extra Backup and InnoBackup tools. Okay, so that's a really good thing for the community. We're taking what was once a closed source, subscription only, you had to go buy a support agreement from TokuDB, and we're making it free now. So we're trying to give back as much as we can to the community. Now, with regards to how we back up InnoDB, I should actually add to that, it also backs up MyISAM. So this tool, Percona Extra Backup, does all of them. It knows, it can look at the versions of MySQL that are, the file format of the data on disk, and it can tell if it's Enterprise, if it's InnoDB Community Edition, or if it's Extra Backup from Percona. And just for reference, MariaDB also ships with Extra Backup. So when you use MariaDB, you're using Percona's version of the underlying storage engine. Okay, even though the MariaDB binary is different than the Percona Server binary in MySQL. There's a lot of moving parts here. But the takeaway from this question about taking backups is that Percona Extra Backup in the long term will be able to handle all three of these storage engines. And today it handles the two variants of InnoDB and also MyISAM. I hope that was clear. Do we have any other questions? Okay, well with that, thank you very much for coming to our show today.